Alrighty, everybody. Welcome to the final review, the last video for this class I'll be making this year. So I'm just doing the odds. I believe that some of you guys are a little bit too reliant on this. And some of you guys just go through and kind of copy down all the answers. This is worth 25 points. I do want you guys to be doing the work, so I'm only giving you the odds. I do have music in the background, which normally I don't do. I'm trying to see if that makes kind of a brain connection. I'll be playing the same playlist during the final, so we'll see how that goes. Okay, so let's get going. On number one. So number one, we're looking for TU. Now TU without any lines over it, without anything else over it, is just distance. Hold on just a second. So it's just distance, okay? So what we know, this is a segment addition postulate. We know that these two parts right here, if I add up the distance from T to U, and then add to that U to V, then I'm going to get the distance from T to V, like that. And then what we do is we go ahead, so this is the yellow and blue make green. I'm not a huge fan of that green, so let's go with that. And then we just plug them in. So we're going to go 3x minus 3. Whoa, oopsie. 3x minus 3 plus x minus 2 equals 7. I know it's ugly, but that's okay. So we're going to combine like terms. So we have 3x minus x, or plus x rather. So it's going to give us 4x. We have negative 3 minus 2, that's going to give us negative 5, equals 7. So we're going to add 5 to both sides. We get 4x equals 12, and we get x equals 3. Okay? Now we're not done yet. That would be a 2-point answer, x equals 3. I want all 3 points. So what I'm going to do is I'm going to put that 3 back in. Go 3 times 3 minus 3, that's 9 minus 3, or 6. Now double check my work. I know that I'm gonna put the 3 in on the other side. 3 minus 2 is 1. 6 plus 1 is 7. What the? Hey, cat. Sorry. Literally, a cat just reached up from the bottom of the chair and like scratched my rib. It was weird. Anyway. So number 3. We're going h plus I, h to I, that distance plus the distance from I to j equals the distance from h to j. So we get x plus 2 plus x plus 5. I put 2x, I'll change that in just a second. So we have x plus x, that's 2x. Plus 2 minus 5 is negative 3, equals 9. So we add 3 to both sides, and we get 2x equals 12. Divide both sides by 2, and we get x equals 6. Again, we need to go plug back in. Here we're looking for ij. So it's that short distance. We're going to go 6 minus 5 is 1. 6 plus 2 is 8. And so that checks because we add those together and they equal 9. So number 5. The same general idea here except we're dealing with angles. And for some reason you guys seem to have a little bit more difficulty with that. So that's what it looks like when it's done. So again, we have yellow and blue make green, and this should make sense. We have that big outside green angle. If we break that big outside angle into 2 smaller angles, the measure of those 2 smaller angles should add up to equal the measure of the large angle. So what we're going to do is we're going to write out our statement, our rule statement. So this is a angle addition postulate. So we're going to go JHI plus GHJ equals GHI. And then we plug in. JHI is 2 plus 12x. GHJ is 12x. That equals 170. We're going to go 24x. That's 12x plus 12x plus 2 equals 170. We're going to subtract 2 from both sides. We get 24x equals 168. Divide both sides by 24, and we get 7. Okay? So we know x equals 7. We're going to plug 7 back in. we're looking for JHI. See right there? That's what it says. So we go 2 plus 12 times 7. And that's going to give us 2 plus 84, or 86 degrees. So the answer to number 5 is 86. Number 7. So here we're going to go the measure of SHG, that's this angle right here, plus the measure of IHS, that's this angle right here, equals the measure of angle IHG. That outside angle right there, right here. See? Okay. So we're going to go 98 plus 17x plus 2 equals 43x minus 4. Combine like terms, we have 17x plus 100 equals 43x minus 4. We're going to subtract, or add 4 to both sides, subtract 17x. And so we get 104 equals 26x. Divide both sides by 26, and we get x equals 8. That's not right. We get x equals 4. So what we're going to do is we're going to plug 4 in there. 4 plus 17 is 98 plus 2. And that is... That's not right. Come on, it's 68 plus 2. And that's going to give us 70 degrees. So if we wanted to check this, what we would do is we'd go 70 plus 98 equals 168 degrees. So if we put a 4 right there, 4 times 43 is 172. If we subtract 4, we get 168. So our math adds up. Okay? So find the slopes of lines parallel and perpendicular to each other. So I've gotten a lot of questions on these so far, which is unfortunate because this is something that you guys learned back in algebra, or at least we're supposed to. So we're looking at all of these are in the form of point slope, y equals mx plus b. Now in that form, m equals the slope, which means that any parallel slopes are congruent. Okay, it means they're the same. Perpendicular slopes are the negative reciprocal of each other. So this is how this breaks down. If we have y equals negative 2x minus 2, then m, our slope, is negative 2. Our parallel slope is also negative 2 because it's the same. And our perpendicular slope is, so it's the negative reciprocal. So we start off with negative 2 over 1. We then apply the negative, so we have 2 over 1. And then we apply the reciprocal, which means we flip the fraction over. And we go 1 over 2. So that's our answer. For number 11, we have y equals 4x minus 4, so our slope is 4. So parallel slope is 4. And our perpendicular slope is going to be negative 1/4, because we took 4 over 1, changed it to a negative, negative 4 over 1, and then flipped it, negative 1 over 4. Okay? And now on to 13. So 13, these 13, 14, 15, 16, they are exterior angle sum theorems. Now what this means, the exterior angle sum theorem, says that the exterior angle of a triangle, right here, is equal to the sum of the two interior angles, right here. So if we add up the two remote interior angles with the exterior angle, not with, but instead equals the exterior angle, that should work. So this looks like this. 19x plus 2 equals 115 plus 3x minus 1. That gives me 19x plus 2 equals 115, or 3x plus 114. I'm going to subtract 3x from both sides. This gives me 16x plus 2 equals 114. Subtract 2 from both sides, I get 16x equals 112. Divide both sides by 16, and I get x equals 7. Okay? And then we plug that in for 3x minus 1, because we're asked to find the measure of angle u. 3 times 7 is 21. 21 minus 1 is 20. So, same general idea. Oh, so it's just 13, 14. So 15, what we're looking at on these next one is whether or not these two triangles are congruent. If these two triangles are congruent, we have to give the reason for determining their congruency. Remember, our reasons for congruency are side, 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 SSS. Side, angle, side, SAS. Angle, side, angle, ASA. And angle, angle, side, AAS. There's also hypotenuse, leg, HL. What there isn't is angle, side, side. Not a thing. Remember, there is no ass in geometry, just me. Okay, so number 15. So let's write down what we have first. So for number 15, we know we got those two sides right there. They're both marked with 3s. We got these two sides right there. They're both marked with 2s. So we're either looking for another angle, side, or a third side, 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 side. Well, here we have this middle side right there. Remember, that's the that is the reflexive property. The reflexive property says that something is congruent to itself. So that middle line, both triangles are sharing it. So it actually counts as being kind of a congruent line on both of them. So we have side, side, side congruency. Okay, now I'm actually going to break my rule a little bit here, do an even for you. And the reason I'm doing this is because a lot of people have been asking about HL. That's hypotenuse leg. Okay, when do we have a hypotenuse? When we have a right triangle. Okay, the hypotenuse is the leg or the side of the triangle across from a 90-degree angle. So that's our hypotenuse right there. And hey, look, it's the same. It's got 2 marks and 2 marks. We then have a leg, and that's the same. So we end up with hypotenuse leg congruency. Now, this is really, if you understand the Pythagorean theorem, hypotenuse leg is really just kind of a cheap way of getting to side, side, side. Okay, so moving on to number 17. Now 17, let's look at what we got. We got a side and the side right there. Now, even though nothing else is marked, there is additional information. We've got our angles right there. Remember, this is a bow tie angle. See, it's like me. I'm right here. I'm smiling because you guys are all working on this. Got legs. Here are my arms. Here's my kilt. See? Here's my shirt. See? Bow tie angle. And they're congruent. Okay? So we now have a side and an angle. And but that's it. We don't have any other side. We don't have a third. We don't have another angle, a second angle, or a second side. So we just don't have enough information here. Now notice that it says, so those are vertical angles. It says not enough information. It doesn't say not congruent. It just says not enough information because we don't. Now compare that to number 18 where we have sides, angles, and then again we have those bow ties angles, the vertical angles, and those are angles. So now look here how on the diagram it goes angle, side, angle, and that means that when we put it into the answer, we're going to use ASA, not AAS. AAS would have been if we had 2 angles and then a side. Here we have an angle, a side, and then the other angle. Okay, number 19. So these rely on your ability to use the properties of isosceles triangles and being able to read the diagram. Okay, so we start off with that 62. Now we know that 62 is the base angle on an isosceles triangle. If you remember isosceles triangles, you know that their bases are always congruent, which means that's 62. Now we notice that 62 is also part of a right angle, which means that it adds up with the other part of the right angle to make a 90-degree angle. So we go 90 minus 62 and get 28. That 28 is also part of an isosceles triangle, which again means that if that's 28, the other one's 28. 28, that left one is a vertical angle, which means that's 28. And then we're going to go 28 equals x plus 37, because remember what we're trying to do here is find the value of x, not the value of angle 2. We go 28 equals x plus 37. Subtract from both sides. And we get x equals negative 9. So I'm going to quick hit pause because I'm going to go make myself a cup of coffee. And I'll be right back. Okay, and we're bad at it. Well, we might be. But we're back at it. Back at it? I don't even know what that means. Apparently, I'm having a little bit of difficulty speaking right now. Back at it. So, number 21, same idea, except, so this one's a little bit trickier. We're starting off with the 76. So we know that if that's 76, then that one's 76. So together, those two, 76 plus 76, equals 152. We know that the interior angles of a triangle have to add up to 180 degrees. So we can go 180 minus 152 equals 28. So we know that's 28 degrees. We know that that right there is 90 minus 28, so that's 62. If that's 62, we know that that's 62. So now we're in a position to find the measure of angle 2. We know that 62 plus 62 equals 124. We know that 180 minus 124 is equal to 56. So we know that 56 equals x plus 70. Subtract 70 from both sides. We get x equals negative 14. So, on to 23. 23 on, we are talking about the, it's called the Mid-Segment Theorem. So, if, like, xw here is a mid-segment, we know that because it's halfway in between, it connects two midpoints. So we know that x is a midpoint, we know that w is a midpoint, so when we connect those two, we get a mid-segment. So we know that a mid-segment is parallel to the third side, but more importantly for this, half the length. So we're going to go x plus 12 over 2 equals x plus 9, or as I like to write it, multiply both sides by 2, and we get x plus 12 equals 2 times x plus 9. Distribute that 2, we get x plus 12 equals 2x plus 18. Subtract x from both sides, we get 12 equals x plus 18. Subtract 18 from both sides, and we get x equals negative 6. Don't freak out, it's fine to have x equals negative 6 as long as our distance isn't negative. So we're going to plug in negative 6 in there, and we get 6. Now I want to double check. I'm going to go 9 minus 6 and get 3, so that works out. On to number 25. Same idea, x plus 30 equals 2 times x plus 20. The long one is twice the length of the short one. We get x plus 30 equals 2x plus 20. 2x plus 40. Subtract x from both sides, subtract 40 from both sides, we get x equals negative 10. We're then going to go and plug that in, and we get 20. Okay, so these next two are tricky, just so you know. I'm going to show you how to do the whole thing, but on the final, I took off that last 5 points of finding the intersection. Not that it's something you guys shouldn't know how to do, it's just something a lot of you guys don't know how to do. And I don't want to penalize you guys for that. So, graph the given line. So we have y equals 5 halves x. So we know that goes through the origin and has a slope of 5 halves. So it goes up 5 over 2, down 5 back 2. That's our line, 5 points right there. Find the equation of the line perpendicular to the given line, which goes through 3, 2. So we know that m equals 5 over 2, m perpendicular is then negative 2/5. So we can graph that right there. Now when we're writing out the equation of that line, what I'm going to do is I'm going to use point slope. So I'm going to go y plus 2 equals negative 2/5 times x minus 3. So that's point slope right there. So then what we're going to do is we're going to take, we know that y equals 5 halves x, and we're going to plug it in there. Now what I'm going to do here is I'm actually going to turn this into decimals. So I'm going to go 2.5 plus x plus 2 equals negative 0.4 times x minus 3. And then we're going to distribute, so we get 2.5x plus 2 equals negative 0.4x minus 1.2, or plus 1.2, because we have two negatives. We're going to add 0.4x to both sides, and we get 2.9x plus 2 equals 1.2. We're going to subtract 2 from both sides, and we get 2.9 equals negative 0.8. Divide both sides by 2.9, and we get x equals negative 0.28. And that looks about right. That looks like it's a little over negative 1/4. Then we're going to take that and we're going to plug it back in. Now I can plug it back into my point slope, but that's going to get messy. So instead what I'm going to do is I'm going to plug it into y equals 2.5x. So I'm going to go y equals 2.5 times negative 0.28. And I get negative 0.69. And again, that looks about right. It looks about 2/3 of the way in between 0 and 1. So our point of intersection is negative 0.28, negative 0.69. It's not pretty, but it's done. Okay, write the name of each polygon. So number 9, we're going to count up the sides. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's a nonagon. That's what it's called. I left out the O there. It's okay. So we know the sum of all of the interior angles is n minus 2 times 180. This is representative of the number of triangles, non-overlapping triangles I can draw inside the nonagon from vertex to vertex. That covers all of the interior angles without overlapping. So we go 9 minus 2 times 180 equals 7 times 180, or 1,260. For a single angle, we're going to go n minus 2 times 180 over n. Now we already did n minus 2 times 180, so we know that's 1260. We're going to divide that by n, which is 9, and we get 140 degrees. Okay? So, the exterior angle, there are two different ways to do this. Okay? So that's where the exterior angle is right there. If we extended a side past the angle, that would be the exterior angle right there. So we can either do 180 minus the interior angle, or 360 divided by n. Now I'm going to do both of them really quickly. 360 divided by 9 equals 40 degrees. 180 minus 140 equals 40. Okay? So it doesn't matter which way you do it, you're going to get the same answer. 31, it's a quadrilateral. Total interior angles are 360. One interior angle is 90. One exterior angle is 90. Okay, Sauvage Proportions, so these are just cross multiplication. So we're going to go 8 times 5 equals 4x. That gives me 40 equals 4x, or x equals 10. Here we go, 7 times x equals 10 times 8. That's 7x equals 80. This one's not as pretty, so we get x equals 80 over 7. So for number 37, what we're going to have to do is, so we start off with the left-hand side, 2x minus 14 over 4. Okay, now we want to set that equal. Now we know that on the other side of the triangle, the 9 is in the same position as the 2x minus 14. But we don't have anything in the position of the 4. So what we're going to do is we're going to put a 6 there, because we went 10 minus 4 to get the 6. So, and then we cross multiply. So we have 6 times 2x minus 14 equals 9 times 4. That gives us 12x minus 84 equals 36. We're going to add 84 to both sides. We get 12x equals 120. Divide by 12, and we get x equals 10. Same general idea on number 39. We're going to go the relationship of 5 to 3 is the same as x to 6. Now notice how I put that x up top is because we were dealing with the same type of measurement, the whole side length. Cross multiply, 3x equals 30, divide by 3, we get x equals 10. Okay. So, number 41. Are they similar? So what we're going to do here is all we have is side lengths. Remember, similarity means proportional sides equal angles. So we can do angle-angle similarity. We can do side-side-side similarity, or we can do side-angle-side similarity. Okay? So what we're going to do here is, if we look down at the answers, they're all side-side-side. So how do we know which ones to measure up? Well, we're going to go long, measure the ratio of long side to long side, medium side to medium side, short side to short side. So we got the ratio of 48 to 36 has to equal the ratio of 36 to 27, has to equal the ratio of 24 to 18. Now, if this is a true proportion, then we're good to go. So what we're going to do is we're going to reduce all those, and we get 4/3 equals 4/3 equals 4/3. Okay, so similarity, so we need to make sure we're matching up the right thing. So notice that we have 3 similarities, but different orders. So we need to make sure, so we have triangle A to B to C, which means we go along the long side, down to the short side, up the medium side. So we need to make sure that when we're saying it's similar, we're matching up those things. The only one that does that, so we know that A to Q is the long side. So we look and we get number C right there, or letter C. 43, same general idea. So what we're going to do here is we're going to take these two triangles separately, and we're going to go the ratio of 7 over 21, because that full side is 21, the red side is 7, the blue side is 21, equals the ratio of 8 to 23. So we get 1/3 equals 8 over 23. And that is not true. So they're not similar. Okay? So find the value of each trigonometric function. We have cosine of A here. Cosine is opposite over, or adjacent over hypotenuse. Whoa. I screwed up my H and my A. Let me go back and... That's my adjacent, and this is my hypotenuse. So that's 18 over 30 reduces to 3/5. If you just want to plug that into a calculator and put 0.6, I'm okay with that. Sine of C is opposite over hypotenuse, or 32 over 40. That reduces to 4/5. Again, if you want to just hit 0.8, that's fine by me. Find the value of the trigonometric ratio to the nearest 10,000. Just plug these into your calculator. For some reason, I switched over and was doing evens there for a little bit. So the tangent of 30 is 0.577. 4, and that is the 10,000. So on these ones, so these are the chart ones there. It's either a 35-35, 35-35, 45-45-90 triangle, or 30-60-90 triangle. So this one's a 30-60-90, which means our base ratio is 1 radical 3/2. If you don't know how to do this, please come and see me before you do these on the final. You can come in at AOT, you can come in after school. So we know that our final is 6, and that's across from the hypotenuse. So we go, okay, well, I know that my scale factor is equal to my final divided by my base ratio, or 6 over 2. So here my scale factor is 3. So then I just multiply across. So my finals are 3 and 3 radical 3. 61, same general idea, except this time I'm doing it with, or 59. This one's a 1 radical 2, because it is a 45-45-90 triangle. So here we have 2 radical 10 over 5 is our hypotenuse. I just did this one completely wrong. This is what happens when you're doing it when you're sick. Okay, so that's our hypotenuse. So here we're going to go 2 radical 10 over 5, which means that our scale factor equals 2 radical 10 over 5 over the square root of 2. Or that reduces to 2 radical 5 over 5. So our scale factor is 2 radical 5 over 5, which means that our sides are 2 radical 5 over 5, 2 radical 5 over 5. Okay. So, number 62. Again, I'm doing evens for some reason, but let's just go with it. So here we have our angle x, and we have the opposite side and the adjacent side. That means that the trigonometric ratio which relates those three is tangent. So we're going to go the tangent of x equals 14 over 26, which reduces to 7 over 13. So we know the tangent of x equals 7 over 13, which means x is the inverse tangent of 7 over 13. I put 17. Oh, 13. Good. Okay. Whew. So plug that in the calculator. I get 28.3 degrees. Now, notice here it says nearest degree. So if my answer comes up as 28.3, I just put 28 degrees. Okay, a lot of people miss points on that on the test. Okay. So 66, we have opposite hypotenuse and an angle. So we know the sine is opposite over hypotenuse. The sine of 21 is equal to 14 over x. Again, a lot of you guys lost a lot of points on the test on this because you just multiplied by 14. You got it as x over 14, so you only got half credit. So what you want to do is you want to multiply both sides by x, divide by the sine of 21, and you get x equals 14 over the sine of 21. Plug that into your calculator, and you get 39.1 degrees. And now here it says find to the nearest tenth, so keep it like that. Okay, so number 67, getting back on track with odds. We have the adjacent and the hypotenuse here. So we go the cosine of 51 equals x, or 12 over x. So again, x equals 12 over the cosine of 51, or x equals 19.1. For 69, we have the adjacent and the hypotenuse. So again, we're going to be using cosine. So we have the cosine of 72 equals 14 over x. That gives us x equals 14 over the cosine of 72. I'm going to check that because I put cosine of 14, so I may have been asleep at the wheel a little bit there when I wrote this. So that should be 14 over the cosine of 72. Let me get out my calculator. Beep, boop, beep, 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 boop, beep, beep, boop, beep, beep, beep. Yeah, that's way wrong. So that gives us 45.3. Okay. Next, what just happened? It's not letting me pinch. Okay. So reflection across the y-axis. Reflection across the y-axis, or reflection across the x-axis, because we're doing 71. Reflection across the x-axis. So if it's on the axis of reflection, it doesn't actually change. So our x-axis is the line of reflection. That doesn't change at all. It just stays there. So I'm going to label my points, label my line of reflection. So the x-axis, all it does is switches the value of the y value, okay? So 0.4 goes to negative 4, 3.2 goes to 3, -2, and that's our reflection. Okay, 72, reflection across the x-axis, or 73. So y equals -1. What we're going to do is draw that line. Now, when we have it not on the x-axis, you just got to count. So v and w are staying put, right? Because they're on the line of reflection. X, however, we're going to count up the line. Oh, we started on? Okay. We're going to start on U. We're going to count up to the line. We get 3 spaces. And then we go another 3 spaces above that to put U prime. X, we count up 2 spaces, so we go another 2 spaces up to get X prime. We then connect the dots. Okay, so 75, rotation 180 degrees about the origin. So when we do something 180 degrees through the origin, that means that there's a straight line and they are equidistant between the origin and through the origin, the point, the pre-image point, and the image point. So this is how we do that. We take H, we draw a line through the origin that connects to H. We then count up and over, up 1 over 2. Repeat, up 1 over 2. And that's H prime. Same thing with G. We're going to count up 4 over 3 to get G prime. We then count another up 4 over 3. Or over 2. And then for I, we're going to do the same thing. We count up 4 over 3. So we go up 4 over 3. And those are our 3 points. Yeah, I don't know what that... Seriously. I felt like I was doing pretty alright on these, but... Okay, there we go. So what we did is we basically took this and rotated it 180 degrees about the origin. And that doesn't matter. Notice it says 180 on the other ones. It says clockwise or counterclockwise. Doesn't really matter here because you'll end up in the same thing. So remember, this is a rotation, so it doesn't change orientation at all. 77, rotation 90 degrees clockwise about the origin. This is a little trickier. So we're going this way because it's clockwise. And what we do is we go H down to the origin, and then we count the slope there. Okay, so that's a slope of up 2 over 3. So any slope, so the line containing its image would need to be perpendicular to that. So negative 3/2. So we're going to go down 3 over 2, and that's H prime. Repeat with I. So I, we go, that would be a slope of up 4 back 1, so negative 4. So that would mean that its perpendicular slope would be 1/4. I fixed that. I'm going to do it right now just in case I don't. So it's up 1 over 4, and I would be right there. I prime. J would have a slope of negative 2/4, which means its positive slope is 2. So we go up 4 over 2. Now we can't, even though 4 over 2 reduces to 2, we can't just go up 2 over 1. We need to make sure we keep the same distance. So we go up 4 over 2. And then finally we have K, which is at 0, 2. So we just flip K over there and we get K prime. Oh, I see. I figured it out. And that's what that kite would look like, rotated 90 degrees. It's not technically a kite, it just looks like one. Okay, so 79. Oh, that was 77. So we're going to do 79, same general idea here. So H would be down 2 over 4. So it's 2/4 would be my slope. So my slope's going to be negative 4 over 2. Now notice I can do two things. I can put it there, or I can put it up there. Now because we're rotating 90 degrees clockwise around the origin, I'm going to put it up there because that's where I know I'm going to end up. So I go up 4, back 2 for H prime. G prime, so it's up, it would be negative 3/4, so I'm going to go negative 4/3. So h is negative 3/2. G is 4/3. And I is, we go from negative 3/5 would be the slope, so we're going to go positive 5. Or positive 5/3, so we're going to go negative 3/5. 81, we're looking for, so if on 80, notice that we're going from the black triangle to the blue triangle, or the pre-image triangle to the image triangle. So how do we get there? Well, what we would do is we would go back 3 spots and down 2. So we'd write that as x minus 3, comma, x minus 2. Okay, 81. So there are two things we can do here. We can either look at this like a reflection or a rotation. And how do we know which it is? Well, let's look at the points. Here's M and here's M. So we're going this way, right? That's M prime. Now, if I had flipped it, if I had reflected it across the y-axis, then that M right there would end up right here. So it would have changed the orientation. Whenever you sit there and look through, look at the orientation, you know that whether it's going to be a reflection or a rotation. So with this one, what we're going to do is we're going to go a rotation 90 degrees, because we know that this line right here and this line right here are perpendicular about the origin. Now notice I don't say clockwise or counterclockwise, because if I don't say anything, it is assumed to be counterclockwise. Okay. So we then have this one. So again, we're going from the black triangle to the red triangle, or blue triangle, sorry. So that's back 1, up 1. So it's x minus 1, y plus 1. And that brings us to 85. Oh wait, so we're skipping the ones with the right triangles. So 85, we went over area. We know that area is, but this is a trapezoid, so we know it's B1 plus B2 over 2 times h. B1 and B2 are our bases. So we go 3.8 plus 8 over 2 times h. Gives us 11.8 over 2 times 3, or 17.7 meters squared. 87 is area of the base times the height. Area of the base times height divided by 2. So we're going 8.8 times 3.4 times 1/2, or 14.96 meters squared. And finally, we have 89. Another trapezoid, 4.7 plus 9.9 over 2 times 4.4. Plug that into a calculator, we get 14.6 over 2 times 4.4, or 7.3 times 4.4. Apparently I was doing this in my head, not my calculator, when I did this, or 32.12. And that's it. Good luck, everybody. If you have any questions, email me or come and see me.